This is problem number 1 from section 7.2. We're trying to find the area of this blue region, which is bounded on top by y equal 1 and bounded on the bottom by y equal cosine squared. So I'm going to draw a typical rectangle, and that's just one of many of an infinite number of rectangles that fill up that space. And so that I can then say that the area is associated with the integral from the top of that rectangle, which is y equal 1, minus the bottom of the rectangle, which is cosine squared x, and then the width of this rectangle is signified by the differential dx. Then I have to say, well, I'm spanning in terms of my x variable from the low end at 0 to the high end at pi. And there we have a description of an integral description of that area. Now they ask us to then find this value analytically. Let's do some work on this. The integral from 0 to pi. And I want to say that you should recognize this as a variation of the Pythagorean identity. Remember that the Pythagorean identity is sine squared plus cosine squared x plus 1, or is equal to 1. If I bring the cosine over, I end up seeing that sine squared is equal to 1 minus cosine squared, which is exactly what I have. So this translates to the integral of sine squared x dx. Now, that step is okay, but there's one other identity that we need to do. And I'm going to write two identities here because they both tend to be helpful, and they show up whenever we see sine squared or cosine squared. And that is, besides the Pythagorean identity, I want to just note that cosine squared x is equal to 1/2 plus 1/2 cosine of 2x. That's not the one that we're going to use in this case, though. What we're going to use is the fact that sine squared x is equal to 1/2 minus 1/2 cosine 2x. Now, if I see that, I know that this can be replaced by that, and I happen to know the antiderivative of that. So let's go ahead and make that replacement. We still have the integral from 0 to pi, but now it's 1/2 minus 1/2 cosine 2x dx. That is equal to, the antiderivative of 1/2 is 1/2 x. The antiderivative of 1/2 cosine 2x is negative 1/4 sine of 2x, and that is being evaluated from 0 to pi. Now I did this portion of the antiderivative in my head, but if I needed to do this out so that you could see it, the negative 1/2 gets pulled out, and I've got cosine 2x dx in the inside. If I use the u substitution 2x, this is du is equal to 2 dx, or I have an additional 1/2 out in front dx, so my substitution becomes the negative 1/2 from here, this 1/2 from the substitution, integral of cosine of u du, and of course there's our negative 1/4, and the antiderivative of cosine is sine of u, or finishing off negative 1/4 and sine of 2x. You can see that showing up right there. All right, let's finish it off by evaluating that. Evaluating at the top end first, I get 1/2 pi minus 1/4, and I'm going to need to know what sine of 2 pi is. And if I remember that, that's 0. There's my evaluation at the upper end. Let's subtract it off by our evaluation at the low end, and I get 1/2 times 0 minus 1/4 of the sine of 0. Of course, that's 0 as well. So I've got a whole lot of zeros going on here. It looks like my final answer is pi over 2.